that is dry hydrogen gas, which is passed through copper oxide, which is solid, black in color, will give you a copper which is solid as a metal, which is brown in color, and some liquid which is water. Once you have an equation, we are told that an oxide of copper weighing 14.39 grams will give us a copper metal of 12.7 grams and 1.8 grams of water. And the question goes ahead, determine the formula of the oxide. Now we determine the formula of the oxide formed. So to determine the formula of the gas formed, already we have copper, which is a solid, with a weight of 12.7 grams, whereas water has 1.8 grams as a mass. We need to find the relative atomic mass of copper, at the same time the relative molecular mass of water. For copper, we've been given that is 63.5, which is also grams, whereas water, the combination of two elements, hydrogen and hydrogen here is a diatomic, so it is 1 times 2 to give us 2, and oxygen has a relative atomic mass of 16 to give us a total of 18 grams as the relative molecular mass. So we are told to determine the formula of the oxide, and as you can see here, we have water. We don't know the grams of hydrogen and oxygen. So there are two ways to determine this. The first one, remember the question is very clear. Dry hydrogen gas was passed over heated oxide of copper weighing 14.3 grams. So that is the mass of the copper oxide before reaction to give you copper. So copper has a mass of 12.7 grams. So if you want to get the exact amount of mass of oxygen, you take mass of copper oxide, that is 14.3 minus 12.7, which is equivalent to the mass of copper. From there you subtract, you get 6, you get 1 gram. So it means 1.6 grams represents oxygen. So you can as well as decide to do it directly now that you know copper as a solid and you have oxygen as a gas. And remember, the relative atomic mass of oxygen is 16, so it is 12.7 grams. This is 1.6 grams from here over 63.5 grams, which is relative atomic mass of copper, over 16 grams, which is the relative atomic mass of oxygen. Here we'll get a total of 0.2 grams, I mean moles. Now we're calculating moles. Moles is equals to mass over relative atomic mass, so that is moles. Here you get 1.1 moles. Then to get the mole ratio, you need to divide with the smallest mole number, which is 1, 0.1. So here will be 2, here will be 1. So copper will be 2, whereas oxygen is 1. So this is the formula of the oxide we are told to give. The other alternative way, remember we have the relative atomic mass of copper, so that will be a little bit direct. But now when you come to water, you need to break it down. Water has a total of 1.8 grams. So we need to find for oxygen. So for oxygen will be relative atomic mass of oxygen over the total, that is the relative the molecular mass of water, then multiply by 1.8 grams. So you'll get 1.6 grams. Then from here you're in a position now to calculate the same using this way, and the oxide you'll form is this. Another thing, if maybe you are instructed to calculate for hydrogen, could be very simple. Could say 2, since hydrogen is a diatomic gas, will have a relative molecular mass of 2 over the total of water times 1.8 grams. You'll get 0.2 grams. This 0.2 grams are grams of hydrogen that was used for the reaction. And this is the end of today's little question. Maybe for further clarification or for further calculations, remember to subscribe to my channel and view and like.